I would like to welcome all graduating students, their families, distinguished guests, friends, faculty, and staff to our departmental graduation ceremony. Welcome. My name's Kathy Clarke. As chair of the Department of Chemistry and Biochemistry, it's my pleasure to preside over this event. It's a great day to celebrate the accomplishments of the Chemistry and Biochemistry graduating centennial class of 2019. Before we begin, I would like to introduce our distinguished guests who are present with us today. They are alumnus Dr. Michael Varney, who we will be hearing a lot more about in a few minutes, his wife, Jennifer Ball, and their guest, Fran Zone. Also with us today is Miguel Garcia-Garibay, Dean of the Division of Physical Sciences at the UCLA College. The official conferring of degrees in the graduate division and the college took place on Thursday and Friday. Today is our special opportunity to bring together those of us in the UCLA community who are associated with the Department of Chemistry and Biochemistry, and to acknowledge and recognize the accomplishments of our graduating Bachelor of Science, Master of Science, and Doctor of Philosophy candidates. As chair of the department, I congratulate you on joining a distinguished family of alumni. We hope that you will continue to consider UCLA and our department your home away from home. We will be proud to count you as a chemistry and biochemistry UCLA Bruin for life. I also congratulate your families, the parents, grandparents, spouses, partners, sisters, brothers, daughters, sons, and other family members who have stood by you and supported you through the highs and lows of your studies. Let's give them a big round of applause. The program for our graduation ceremony is as follows. We will begin with the presentation of the annual Alumni Award and the Commencement Address by Dr. Michael Varney. We will then confer graduate awards and then honor the PhD and master's candidates. After that, we will award the undergraduate prizes and honors. And finally, we will recognize each of the bachelor's candidates. At this point, I would like to welcome Dean Miguel Garcia-Garibay to the stage to present the 2019 Chemistry and Biochemistry Alumni Award.
Well, thank you for joining us for the Chemistry and Biochemistry Commencement Ceremony. I must say that in addition to being the Dean of Physical Sciences, which is of course a great honor, the greatest honor is that I am a member of this department, which I think is the best department in the physical sciences. Absolutely. Now, of course, today is a very special commencement celebration because, as Chair Clarke, you said, this is a centennial occasion. So you will always remember yourselves and you will be remembered as the centennial class. And basically, what you are is you're the beginning of the second century of UCLA. And I think you just put us in an incredible pathway for something truly, truly remarkable. But let me tell you about the Department Alumni Award. It was started in 2012 to recognize the outstanding contributions of our alumni, the contributions that they have made both to science and to society. Now, with such a great history of distinguished alumni, you might remember that we have several Nobel Prize winners, Olympic medal winners, and others. There are many individuals, and I should say also people who have really made a strong impact in our society, in our economy, in many different ways. So there are so many individuals who could be deserving of this award, so this makes a very difficult process for the selection. But today we have someone who's absolutely special. It is my great honor to present the 2019 Chemistry and Biochemistry Alumni Award, Dr. Michael Varney. I will tell you a few words about Dr. Varney. But you should know that he received his bachelor's degree in chemistry from UCLA in 1980. As a UCLA chemistry undergraduate, he conducted research in the lab of Professor Michael Young. Dr. Varney went on to receive his PhD in synthetic organic chemistry from the California Institute of Technology and was the American Cancer Society postdoctoral fellow at Columbia University. Dr. Varney is currently the Executive Vice President and Head of Genentech Research and Early Development, or gRED. And he is a member of the Roche Corporate Executive Committee. He is responsible for all aspects of gRED innovation, drug discovery, and development. In 1987, Dr. Varney was one of the original 15 employees at Auguron, a San Diego-based biotech company. He and his team pioneered the process of protein structure-based drug design. From those efforts came Viracept, an HIV protease inhibitor, and a number of anti-cancer agents, including Salcori, Inlera, and Rucaparib. I don't know about you, but I always find this, the number of drugs extremely interesting and hard to pronounce. Dr. Varney was recruited by Genentech in 2005 to take the company beyond biologics and create a small molecule drug delivery capability. Within 10 years, his group had produced almost 40% of gRED development portfolio, including anti-cancer agents Erivedge and Cotelic. It is now my pleasure to invite Dr. Michael Varney up to the podium to accept his award and present the commencement address.
Got to put it back safely there. Well, it's a pleasure to be here, and certainly I thank very much Mike Jung, the Dean, and Dr. Clarke for inviting me here. Certainly a surprise, and certainly thank you all for the kind introduction. Congratulations. It's like a major milestone in your life. UCLA is where I became a scientist and where I met my wife of 33 years, Jennifer Ball. I'm proud to be an alumni at UCLA, and I'm proud to welcome you to those ranks. I was a proud member of the class of 1980, and as mentioned, worked for Mike Jung in the last year. And I was in your seat a measly 39 years ago. Today, I am a husband, and I am a dad, and I am still an introvert. I am a mediocre guitar player and a founding member, along with my wife, of the band The Finger Puppets. You can look us up on YouTube. I'm a lifelong student. I'm also a builder, ranging from drug discovery teams to beautiful gardens. I am very straightforward, and I love to cuss. Don't worry, I've edited them all out. Just to get to your seat was not simple for me. I was a curious introvert who couldn't communicate and was pathologically addicted to the unknown. I had a head full of ideas and no skills to communicate them. When I graduated from high school in 1976, it was much easier to get into UCLA at the time than it is now. This was lucky for me because I scored in the 33rd percentile in the verbal section of the SAT. That means that 67% of the nation at the time scored higher than I did. Before I set foot on this campus, I had to attend a junior college to take what was commonly known at the time as Bonehead English, also known as Pre-English 1, a course I had to take twice. So I did. The second time was upon arrival at UCLA. Had to take an English proficiency exam, which I failed, and therefore had to take Bonehead English the second time. This experience was both frightening and motivating. It led me on a lifelong journey to build my reading, writing, and speaking skills. Words have power. The wrong words can disengage. They can disconnect. The right words can inspire and motivate. Word choice is essential to the ability to effectively communicate your thoughts, your ideas, and direction. I even went so far as to marry a writer, a word expert, to help me along the way. I have to say that these skills are also essential to a successful marriage. When I graduated from UCLA in organic chemistry, making molecules was the state of the art. The question was all about, can we make this molecule? To provide some perspective, there was no internet, there was no iPhones, and there were no HPLCs. The NMRs were 60 megahertz machines. In fact, the iPhone sitting under your gowns today has more memory and more compute power than the mainframes did at the time. The edge now is about making molecules that make a difference. We need to make molecules that can do things that no other molecules have ever done for patients, like selectively kill their tumor cells, leaving their healthy cells alone. In my graduate training, I worked for Bob Ireland at Caltech for 5 years and did a 2-year postdoc at Columbia with Ron Breslow. As I completed my formal education, was about to enter the job market, Bob Ireland gave me some very valuable advice. Mike, you turn down offers, not opportunities. In 1987, I took my first real job at a new biotech called Agaron in San Diego. Agaron was the first chemistry biotechnology company and the first company dedicated to developing structure-based drug design as a tool in small molecule drug discovery. Old news today, but big news in 1987. I was one of Agaron's original 15 employees. Agaron was only able to exist because of the rapid advances in computing technology. As an example of the power of these advances, solving the structure of a protein used to take about 5 years. It was a PhD. At Agaron, eventually we could solve them in an afternoon. I went to a small company because I was worried about disappearing into a giant pharma organization. With our technical skills at Agaron, we developed Virusept, the most widely prescribed HIV protease inhibitor. It is estimated that in the first year after launch, over 100,000 people's lives were saved. Today, technology is a key driver of our success in small molecules at Genentech. Almost half of our portfolio are small molecules, and in 2005, when I joined the company, that percentage was 0. Genentech recruited me to create and build their small molecule drug discovery capability. I'm a builder. I like to do things that nobody's done before. Couldn't wait to say yes. Now, this was a big risk for Genentech, not because they were hiring me, But because many large biotechs had attempted to add this capability to their armamentarium, they all failed. Within 3 years of my arrival, we had built a productive organization with 2 molecules in the clinic, 4 molecules on the way, and by year 5, the small molecules comprised roughly 40% of Genentech's portfolio. Achieving this milestone allowed us to be recognized as the first small molecule drug discovery organization to have any success in the large biotech industry. Soon after that, I was invited to lead the entire Genentech research and early development organization. And because I stand in front of the next generation of chemists and biochemists, you, I feel it's important to point out that I am the first chemist to lead the entire R&D organization at Genentech. Prior to that, all of the leaders were biologists. Your opportunities are limitless. You're stepping into a world where molecule-making skills matter more than ever. In drug discovery, good targets are hard to find. The human genome is finite. There's only roughly about 20,000 genes, and druggable target space is even more finite. All the simple targets have been drugged. What is left are the hard ones. So your opportunity is to make the molecules that were unmakeable, to drug the targets that are currently undruggable. Sounds like a tall order, but the technical tools available now are infinitely more powerful than they used to be, and they are only growing in their power. My addiction to the pursuit of the unknown has always been a driver in my life. I assume this is true for all of you. Like you, I would rather be at the edge. The line that divides the known from the unknown. The place where no one's been. No person's land. In no person's land, there are no rules. You get to make them up. For me, this is freedom. What is unknown will change, but the importance and the value of pursuing the unknown will not. Think of yourself as pioneers. Pioneers go where no one has gone before, and they find things that no one else has found. Common among all of the pioneers that you know the names of is a team of people working together. Drugs come from teams. Your success requires the ability to collaborate within an inclusive team that values diverse perspectives and thinking. People who can communicate and collaborate across discipline boundaries will own the future. Crossing disciplines requires learning new language. When a chemist speaks to a biologist, they need to use the language of biology. Most of the language we use today was invented roughly 5,000 years ago during times of little diversity and zero inclusion. Which brings me to bias. Our social fabric is built on preconceived notions and unstated assumptions. Most bias is unconscious and hard to identify. Bias is not absolute. It leans. Bias supports preconceived beliefs. That is what makes it so subversive and dangerous. It closes off solution space. How can you out-innovate your competitors if your language is non-inclusive and built on archaic fears? There are biases in our language that exclude large groups of people. Think of our use of the words dark and black. When we use dark or black metaphorically in our language, they are demonstrably bad. The dark side, blacklist, blackball, black sheep, black box, and blackmail. This is not inclusive language. I no longer use these cliches. I call out the people in my organization who use them. Words are tools. They can be used to exclude, or they can be used to include. We need to replace exclusive words with inclusive words. We've made some progress with sexism. Chairmen are now chairs. Stewardesses are now flight attendants. Why can't blackmail be extortion? Why does this remnant of the past remain in our language when we have a perfectly suitable substitute? Why can't blackball be called what it is? To exclude. All of us must face and understand our own biases. They are limiting, they are discriminatory, and they have no place in science. As scientists, we make drugs that save lives. By changing our language, we can drive the changes urgently needed to collectively save our planet. Which brings me to leadership. Something sadly lacking when it comes to the saving our planet topic. Since you are the future leaders of science, I thought I would share with you some of my learnings on what successful leaders do. First of all, they listen. It is a way that leaders show that they care. Active listening is a communication skill. Great leaders listen more than they speak. Good leaders tell the truth. Truth-telling leaders create truth-seeking organizations. Good leaders inspire excellence by using positive reinforcement. Contrary to the knuckleheads in Washington, you cannot humiliate people into excellence. Good leaders lead with facts, not beliefs or opinions. And good leaders build diverse teams and don't surround themselves with people just like them. Good leaders collaborate, they connect, and they catalyze. I'd like to conclude by stating the obvious. Science and technology march forward. There's no stopping it. We all have a choice. We can long for the past, protect current positions based on old beliefs, or we can lead with science. Choose science. Choose inclusive leadership. The future depends on it. Thank you.